Welcome to part two of the electricity notes. My goal is to make this very quick, but as you know, I like to talk, so that's probably not going to happen. I'll try to make it very fast, though. Look at me, I'm already babbling. Okay, Ohm's law. We're going to just talk about how to do calculations quick, and the calculations are going to be what I would consider very similar to our first trimester of calculations in the sense that there are three variables, and we're going to give you two. You need to solve for the third one. So the first one I would write down is this right here, resistance equals voltage divided by, and this is kind of weird, and I'll talk about this in a second, current. So the symbols, V is going to be voltage, which oops, I spelled voltage wrong, which we're going to measure in volts. I is going to be current, which if you remember, we measure that in amps. And R is resistance, which we measure in ohms. And another way to write ohms, and this is actually kind of fun, I like this, it's the omega symbol. So it looks like this. That is those are the units right there. So I'll draw it again over here so you can kind of see it. It's not covered up by the logo. That is ohms right there. Kind of looks like a horseshoe almost. So yeah, there you go. So very quickly, before we get too far into it, I always like to make math triangles, and you can take it or leave it if you want. But essentially, the triangle that we will be using for these calculations look like this. We have on top, we have V, which is voltage or volts. On the bottom, we're going to have R for resistance, and we are going to have I for current. So what do I do when I'm trying to solve? I'm going to cover up what I'm solving for. So if I'm trying to solve for current, I'm going to cover up the I, and it's going to say current is equal to voltage divided by resistance. If I'm trying to solve for voltage, I'm going to cover up the voltage, and it's going to say resistance is equal to, or sorry, voltage is equal to resistance times current. Sorry, I just realized I covered it up with my finger, and that didn't really show on the screen. So anyways, here we go. All right, so a couple practice problems we're going to go through. I'm just going to go through all of these just to kind of give you a little heads up. So first one, we are trying to find ohms. We have volts and amps. So ohms are resistance, which means R is equal to volts divided by current. So if I take my 100 volts, divide it by 25 amps, I'm going to get a resistance of 4 ohms. Let's see if I did that right. Fingers crossed. Look at that. Very nice. We're good to go. All right, so I am going to just do one practice problem for each one. So we already got that one. On your own, if you want, you can do the math and try to figure those two out. Essentially, if we take that first, I'm going to look at an example problem for voltage. So this middle, or the second to last one right here, we have volts. We're trying to find volts. And it's going to be equal to resistance times current. All right, so there is my formula. We have a resistance of 9. We have a current of 5. Sorry, I forgot my units there. Let's redo that. It's 9 times 5 amps. I believe the answer is going to be 45 volts. And if we cover that up, it is 45 volts. Last one, and then we'll be done with the notes. Trying to solve, in this case, for amps. Amps are going to be, if we look back up at our triangle, cover up the I, we have volts divided by resistance. So we are going to say V divided by R. So here's our formula. We have a voltage of 48 volts. We need to divide that by our resistance, which in this case is 6 ohms. 6 times 8 is 48, last I checked. So 48 divided by 6, I'm going to get an answer of 8 amps as my current. Draw a little arrow so we know what we're talking about there. All right, let's see what we get, and we're good. 8 amps. So that is how you do Ohm's law calculations. Best of luck.